Now we will talk about the fundamental atomic structure. This is the atomic structure that you can see out here. We have some electrons, protons, neutrons. These pink colored circles are called the neutrons. The green colored circles are protons, and these blue colored circles are shown as electrons. So every atom consists of a small nucleus composed of protons and neutrons, which is encircled by moving electrons in their orbital. So this is your nucleus where the proton and neutron lies, and just outside of that we have some electrons which is encircled around. So the combination of protons and neutrons where they lie are called the nuclei. Okay. The topmost orbital electrons are called the valence electrons, which affect the most material properties. So the outermost electrons present in the outermost orbital, so these electrons are called your valence electrons, and generally they affect the material properties. Electrons and protons are negative and positive charges of the same magnitude respectively, being 1.6 into 10 to the power of minus 19, which means the charge with an electron is 1.6 into 10 to the power of minus 19 coulomb. Similarly, the charge of proton is 1.6 into 10 to the power of minus 19 coulomb. So electron is negatively charged and protons are positively charged, but they do have the same type of magnitude. And neutrons are electrically neutral. So if the neutrons are neutral, as you can see out here, so you can say very well that neutrons are neutral and protons are positively charged. So what will be the charge of this nuclei? So the nuclei, overall the charge of the nuclei will be positive. Okay. Protons and neutrons have approximately the mass, that is 1.67 into 10 to the power of minus 27 kg, which is larger than that of the electron. So we have the protons and neutrons which have the mass, the mass of the proton is 1.67 into 10 to the power of minus 27 kg, whereas the mass of neutron is 9.11 into 10 to the power of minus 31 kg. So you know that from this figure we can say that protons are quite heavily charged, that is, the mass of this proton is quite high or large as compared to the mass of neutrons. So neutrons are lighter and protons are heavier. So here, the protons and neutrons have this mass 1.67 into 10 to the power minus 27 kg, but the mass of electron is 9.11 into 10 to the power of minus 31 kg. So protons and neutrons are heavier than electrons. So what is atomic number? So we have atomic number, nothing but the number of protons per atoms, or rather number of electrons per atoms. So atomic mass is the sum of the masses of protons and neutrons within the nucleus. And atomic mass is measured in atomic mass unit, which is AMU, where 1 AMU is equal to 1 by 12, the mass of the most common isotope of carbon atom, which is measured in grams. We can symbolically write as atomic mass A is equal to Z plus N, where Z is your atomic number, where Z is the atomic number which is nothing but the number of electrons or protons, and N is the number of neutrons. A mole is the amount of matter that has a mass in grams equal to the atomic mass in AMU of the atoms, and thus a mole of carbon has a mass of 12 grams. The number of atoms or molecules in a mole of a substance is called your Avogadro number. So 1 Avogadro number is 1 gram per 1 atomic mass unit, which is nothing but 6.023 into 10 to the power of 23. So most solid materials will have the atomic density in the order of 6 into 10 to the power of 22, that is about 39 million atoms per centimeter. So mean distance between the atoms is in the range of 0.25 nanometer, and it gives an idea about the scale of the atomic structures in solids. Okay, so these were some important points related to your atomic structure. We will talk about some new topic in the next video. Till then, bye.